Hi everyone, this is the part 2 of my respiratory physiology series and I'll be talking about mechanics of breathing. Now see, breathing involves two processes, inspiration and expiration. And during inspiration and expiration there are two muscles involved, which are namely the diaphragm and the intercostal muscles. Now I will talk that the expiration is not that moved by intercostal muscles except if there is a forceful expiration, but let's talk you can say serially. So if I talk about the inspiration, so inspiration, there are two muscles involved, the diaphragm and the intercostal muscles. If I am talk about a diaphragm, the diaphragm is a dome kind of a structure which arches and separates the thoracic cavity and the abdominal cavity. Now it has a portion, a tendon, which is highlighted here with a green. This is called a central tendon. You see this image here, this is has taken from, you can say, a downward view of the diaphragm. If I see the diaphragm from the abdominal cavity, then I get this view. So this part here you are seeing here, this part is the central tendon and these are the peripheral muscles. Now if I try to pull on this central tendon, and obviously the muscles, this red portion is originating from the ribs, and if I try to pull on the central tendon, what will happen? This dome will flatten out. If this dome is arched like this, then it will become less arched, it will flatten out. So what will this cause? It will cause the longitudinal expansion of the lungs, and that is how diaphragm helps. And the diaphragm is very active because it is the muscle which is majorly involved during our inspiration and expiration, and it has to stay active all the time. So basically, because our inspiration is more of a thoracic, or you can say more of a diaphragm type of a respiration, in which the diaphragm is involved more. If I talk about the intercostal muscles, their role in inspiration, so you see this external intercostal muscles. There's a zoomed out figure here of the left side of our thoracic cage. If you see it here, then you see that the fibers are running in this direction. Now there's a very cool thing here. Now these fibers which are running in this direction, what happens is that they arise from the upper rib and they insert into the lower rib. Like this one is the upper rib and this one is the lower rib. So when they insert into the lower rib, they try to pull the ribs in these arrows you are seeing, the direction of the force is here. So what happens is that it, how does it cause respiration or inspiration basically? So if I break down this force vector, if I apply physics here, then there will be two parts, a horizontal part and a vertical part of this force vector here. This force vector, if I demarcate by arrows also here. So if I talk about this horizontal part, see, the ribs can't move horizontally because the ribs are fixed. They have been made like that they won't move horizontally. But if I talk about the horizontal part, then yes, we can move the ribs kind of vertically and upwards. How will it be possible? So you see at the sternal region, these costosternal joints, they are a bit flexible. They are a gliding type of joints which allow the sternum, since these ribs are being lifted upwards. So what happens is that this force is also transmitted to the sternum and it is also lifted upwards in this upward direction. These arrows show the upward direction. So what this causes is that the transmission of tension to the sternum causes the sternum to be lifted upwards. Now if I talk about, if I take this lateral portion of this rib here, so this rib also is being pulled upwards. Now if all the lateral ribs are being pulled upward in this direction by I'm showing in the arrows, then what will happen? They will expand laterally. They will, since they're trying to go upwards, they can't go horizontally, they can only go upwards. So the costovertebral joints which are present behind the back, so this costovertebral joints allows some movement, and you can say it is a kind of a bucket handle movement. Yes, that is what I was trying to imagine. So in a bucket handle, if you consider the, you can say the vertebra to be the bucket through which the ribs are attached, which is the handle, then if you move this handle upwards and downwards, then this bucket which has hinges around it, it allows the handle to be moved upwards and downwards. If I try to push this upward, if I try to push this upward through a upward force, it will move upwards. So that is what being applied to the ribs. If you imagine this rib to be a bucket handle and our vertebra to be, you can say, the hinge of the bucket, then the ribs are moving upwards. That is what happens in inspiration. Now if I talk about the expiration, then in expiration, see, the lungs are an elastic tissue. So expiration is not, you can say, something which we do by will. It happens due to the elastic properties of the lung, which allow it to shrink it back, because the lung has a tendency to collapse. It is very elastic. It is made up of a lot of elastic tissues. So that is why as soon as we inspire, it contracts back and it shrinks back to its own position. But hey, you must have observed that expiration is not that sudden too. If it happens that suddenly, then it will not be that regulated. The expiration has to be a little bit slow, because if the lung is left on its elastic properties to allow it to do expiration, then it will be very fast and unregulated. That is why these intercostal muscles play a role. Now what do the intercostal muscles do? See, you see their direction, they are just perpendicular to the direction of external intercostal muscles. So what they do is they arise from the upper ribs and they attach to the lower ribs, but they pull the ribs in this direction. Basically what happens is that they pull the ribs downwards. So if I try to pull the ribs downwards, then what will happen? See, if I try to pull the ribs downward, then the sternum, instead of going upwards, it will go downwards. It's the same thing which you apply to a bucket. When you pull the bucket upward and the handle is here, and then you try to pull it downwards, then the bucket will swing and it will come back to its own position. That is what is happening there. If you imagine the same for the ribs, then that is what the internal intercostal muscles are doing. They are trying to pull it downwards. You see here, if I talk about the internal intercostal muscles, if I zoom this out, then the force vector here is kind of like this. Now this also has two components, the horizontal and the vertical components, which is pointing downwards. Now if I talk about this horizontal component, let me use green color for expiration. Yes, if I talk about the horizontal component, then it is useless because the ribs can't move horizontally. You can't pull out the ribs, but it can move downwards by the virtue of the costosternal and costovertebral joints. So just like the bucket handle, it moves downwards. So that is the the role of inspiratory muscles and diaphragm in expiration. And the diaphragm also, when it contracts, it flattens out, and when the expiration is going on, the diaphragm regains its position and it again becomes a dome shaped structure, just like this. Just like this, and the lungs go back to their original position, and also by the virtue of the elasticity, obviously. That is why we don't forcefully expire. We do inspiration has some effort, but expiration is not that effort. You can say generally when we are exercising very heavily, then only the expiration is, you can say, not effortless. If I talk about the lung, then the lung is covered by a membrane called pleura. The pleura has two parts, the parietal part and the visceral part. Now the parietal pleura is firmly attached to the chest wall and the visceral pleura is attached to the lungs. Now you see, the parietal pleura is also the part of the lungs. So the chest wall will also move, then the lungs also have to move together, because obviously the chest wall and the lungs can't move separately. If that will move, then lungs will collapse and the chest wall will move outside only, because the chest wall has a tendency to expand. It can expand by our will, but the lungs can't expand. You can say they have a tendency to collapse. That is why we gave this parietal pleura and attached it to the chest wall, so that even if the lungs want to collapse, it has to move with the chest wall. And between this parietal and visceral pleura, there is a pleural fluid which allows frictionless movement between the two fluids, between the two layers. Sorry. So, what are the pressure and the volume changes during inspiration and expiration? So the pressure and the volume changes are what happens is that whenever, if I talk about the pressure in the alveoli, the lungs are expanding. If I draw this lung, then the lungs are expanding. So by the virtue of the inspiratory muscles and the diaphragm, the lung expands, and since the chest wall is moving also during this inspiration process, the lungs also expands. Now since the volume is increasing, the pressure decreases, and when the pressure decreases, it becomes negative. And just as lungs regain their, you can say, original shape and size due to their elastic recoil properties, and the air is expelled out, then again we see volume decreases, and since the volume decreases, pressure also increases. You must have heard about this in Boyle's law, where if pressure is inversely proportional to volume at constant temperature. And if I talk about the intrapleural pressure, then what is the intrapleural pressure? See, the intrapleural pressure is the pressure which is present between the parietal and the visceral pleura. If I take this portion of a lung and zoom here, then this one is the parietal pleura, this green color, and here the red color is the visceral pleura lining the lung. And the parietal pleura is also a part of lung, but it is attached to the chest wall. So the pressure, this pressure here, which is between these two layers, is the intrapleural pressure. What happens when we inspire is that our chest wall moves outward, and this parietal pleura also moves outward. Now, since the parietal pleura is also the part of lung, and it is not that it is separated from the visceral pleura, they have a fluid in between, but it's like, two glass slides which are stick together. When you add water between two glass slides, they get stuck together due to surface tension, or you can say the sticky nature of the water. You must have seen this practically. So that is what is happening there. Since the parietal pleura also moves, then the visceral pleura also follows. But let me use a different color. Yes, the parietal pleura stands for green, and the visceral pleura stands for red. So what happens is that since the lungs have a tendency to collapse and have a kind of an elastic recoil property, they don't move that much. Since the visceral pleura lines the lung and is very in close proximity to the lung, it does not move that much during respiration in comparison to the parietal pleura. And that causes this volume to increase. Earlier, if the volume was less, the intrapleural, you can say the volume in the between the two pleuras was less, then it increases you can say it increases. Then this increase in volume causes the intrapleural pressure to fall. Intrapleural pressure falls. And again, since this pressure is negative, it allows the lung to even expand more. It helps it in expanding more, because if I apply a positive pressure over here, then it will try to push and compress the lungs. But if there is a negative pressure here, always, if the volume is trying to, you can say, if the volume is always trying to increase, then see, the more negative the intrapleural pressure, the more it allows the lung to expand, because there is a kind of a vacuum being created here. And if there is a vacuum, it tries to suck, or you can say keep the two pleura even more stuck to each other. Because if this negative pressure is not there, then this two pleura will separate, and this separation will cause the lung to get compressed. That is why negative pressure is required. And I told you the origin of this negative pressure, that why it exists. And also this negative pressure is also there due to lymphatic absorption, which is actively occurring here, and that is why the intrapleural pressure is negative. So during inspiration, since though it has a negative value, but it becomes even more negative. See, the origin was already negative due to the lymphatics and what I told you about. But when the expansion occurs, it becomes even more negative. Just like, because the visceral pleura does not want to move outwards that much by the virtue of the elastic property of the lung, but the parietal pleura moves. But it's not like that the visceral pleura does not move at all, because obviously they both are not that separate or some kind of a separated layer. They both move together. But since the parietal visceral pleura does not move that much, and the parietal pleura moves much more because it is attached to the chest wall, the volume increases a little bit, and that little increase in volume only causes the pressure to fall this much. And then again, during the expiration, the pressure returns to its normal value. So that is what happens to the intrapleural pressure. And if I talk about the volume of the breath, then slowly, obviously, the volume of the breath has to increase. And when we expire out, then the air is expired out. We take 0.4 liters of breath, and then when we expire it out, then the volume of the breath in our lungs again decreases and comes to zero. The volume of breath, not the air. It's not that the lung have no air when we expire out. You can say the air. You must have heard about the residual volume. So that is it for today. I explained the mechanics of breathing and all the basics related to it. I hope you understood this video and my explanation, which was a bit detailed, but yes. And if you like this video, comment on the comment section, and please subscribe to our channel, M.B.B.S Nerd. I will see you in the next video. Till then, bye bye.